So let's continue with the law of signs. We're going to talk about the ambiguous case, which is basically the SSA case or the AS case that I like to call it. So here what we have is that we are going to be given the angle A, side A, little a, and side little b. So here we have the angle side case. So three cases can kind of occur from this. So I'm going to label this case 1, case 2, and case 3. So the first thing is actually the easiest one. So also I picked little a and little b for no apparent reason. I could have easily said big C, little c, and b or whatever. So it doesn't necessarily have to be b. So in order for you to have no triangle is, for example, let's say the angle for here was too short. It was a really small angle. If this is a really small angle, that means that this side is going to be really, really short also. So sometimes what happens is that this guy is so short that it will not reach out to be a triangle. And the way that you can find that is when you're trying to figure out for one of the other angles. So for example, angle B would exceed something that is outside the range of sine. So sometimes you will get no triangle in this case. So that is one of the cases that you can kind of obtain. So another case will be one triangle. So here I can just gonna say it's too short. So the side of angle A is gonna be too short for it to reach all the way to B. So what about if you have one triangle, okay? So if you only had one triangle, this means that it's just right. Okay, so the side of A is just right. It immediately touches the angle B. Oh, I forgot B there. So it's just going to touch it. It's just going to be a perfect size. Usually what happens is that when you're solving for the angle of B, you can, if it's 90 degrees, you can already tell that you're going to have a right triangle. And if this exists, then you're pretty much set. Okay. Now you have to be very careful because sometimes this B, you can have two triangles. And that brings us to the third case. So let's say you kind of had this guy. Okay. Just basically this guy. So here is one triangle. Okay. So this is basically the first triangle. Now, how do I know if a next triangle exists? Well, if I were to kind of swing this guy over, okay, so that I swing it this way. So like, let's say if I had this guy, so here's B1, and let's say I just swing this guy over here. So now this is my new B2. So now I made this angle C much smaller. Okay, sometimes if the measurements are correct or really good, you can create a new triangle, two different triangles. So this is going to be the second triangle. Okay, so it really just depends on really what the measurements kind of look like. So so these are basically the three different cases when you can have with the SSA or the ASS case. Okay, so here what I created was kind of like a little guideline. Kind of keeps you in check. So basically, if the sine B is equal to 1, then that means that theta is 90 degrees. Oh, maybe I shouldn't say theta. Maybe I should say B. Then beta, or B, is going to be equal to 90 degrees. So only one right triangle exists. So here it's just basic. You just have a one right triangle. Okay. Usually this doesn't occur, but just keep that in mind. This one, you pray to the trig gods that you get number 2. So if you get this guy, which is kind of give you on the calculator a domain error. So if you end up getting a domain error in your calculator, then no triangle exists and you are done. You don't have to do anything else. So usually this is the one that everybody just hopes that you get. Okay. We really pray that we don't get the third one. So the third one, basically what it says is that let's say when you calculate the value of B or the sine B, you end up getting a number between 0 and 1. Then you have two cases. Either one triangle is going to exist or two triangles are going to exist. So if one triangle exists, how am I going to figure it out? So first you're going to have that, okay, sine b is going to be equal to k, so some value k. So I'm going to find the angle by taking the inverse of the sine, okay, so that kind of makes sense. So that's going to be the measurement for the first triangle, okay. Now how do I know if I have the second triangle? Well, you go to part B. You're going to take B2, so this second triangle, the second angle would be 180 minus B1. So how would you know if that other triangle exists? Well, if the angle that they gave you in the very beginning of the problem plus this new angle is less than 180, then a second triangle exists. If it's more than 180, then no triangle exists. Okay, or greater than or equal to. Okay, so I think the best way to kind of do this is to do a couple of problems because this can be really confusing. I think the only thing that I will kind of explain is why would we have to subtract it from 180? And it basically just depends on, it's just basically the measurement of oops, all students say calculus, okay. So it's basically where all the angles of sine are. So sine, usually when you take sine inverse, you're going to get a triangle that maybe looks like this. So let's say here. Okay, so I'm not drawing this right. So when you do this sine inverse, you're basically gonna have an angle in here. Okay, somewhere in here. Now, if you switch it around, okay, all the way over here, notice that you're gonna have an angle here. Okay, let me see if I can explain this right. Okay, so when you do the first sine inverse, because of this restriction of sine inverse, you know that it's going to land in quadrant 1 because that's where you're going to get the positive angles. Where else is sine is positive? Sine is positive in this direction too, in quadrant 2. So that means you can also get a positive angle here. So how can I get this other angle? Well, a way that I can find this angle is by taking 180, because this is 180 degrees, or pi radians. Take 180 minus this reference angle. Okay, so that's how you're going to get this new angle. So that's where the 180 kind of comes from. Okay, if you got it, great. If not, it's okay. All right, so let's do a couple of examples. Okay. All right, so let's say we want to find this problem. Okay, so oh, no. Determine if one triangle, two triangles, or no triangles exist. Solve for the triangles if they do exist. Okay, so we're going to solve for the triangles in case they exist. So let's say we are given that big B is equal to 68.7 degrees. Little b is equal to 25.4 inches. And little a is equal to 19.6 inches. Okay. All right, so now let's go ahead and draw a triangle first. So I'm just going to draw a generic triangle, not drawn to scale. So I'm going to say this is B. Okay, this is going to be A and it's going to be C. So this B is going to be equal to 68.7 degrees. That means B is the other value, little b, is going to be right across from it, which is going to be 25.4 inches. Here is A, so right across from it is going to be little a, which is going to be 19.6 inches. So here you can see that you have the angle side case, which is the as case. All right, so now what you want to be able to do is, well, this is basically the ASS case, or you can write the SSA case, whatever you want to write. So now what we want to be able to do is figure out what exactly will be if you're going to have one triangle, two triangles, or no triangles. So let's just look at what we have. So obviously I have to use the measurements of B. Okay, so I have to use sine B over little b. It's going to be equal to, well, the other one that I have to be forced to look at is A with big A. Okay, so I'm going to equal it to sine A over little a. So let's see what happens with sine A. So sine A is going to be the one that I'm going to be taking a look at, because depending on that, well, if it's equal to 1, I'm going to have a right triangle. If it's greater than 1, you're going to have no triangle. And if somewhere between 0 and 1, then I might have 2 triangles. Okay, so let's see what happens. So sine B is going to be equal to 68.7 degrees. Little b is going to be equal to 25.4. Sine A is what we're trying to figure out. And little a is going to be equal to 19.6. All right, so now what we're going to do is cross multiply. So we're going to have 19.6 sine of 68.7 is equal to 25.4 sine of A. I'm going to divide by 25.4 to both sides. So this is going to go away. So I have sine of A is equal to 19.6 sine of 68.7 divided by 25.4. All right, so let's figure out what this is. So let's put it in the calculator. So I'm going to have 19.6 sine of 68.7 divided by 25.4. And what you're going to get is 0.7189. Okay. So now what I'm going to do is I'm going to take inverse sine. Okay, so I'm going to take sine inverse to both sides. So basically you have A is equal to sine inverse of 0.7189. Now notice here that clearly I'm not going to have the first case because this number was less than 1, so we might have the second case. So here A is going to be, so let's take the sine inverse of this 0.7189, and what I'm going to end up getting is about 46 degrees. Let's just say that's 46 degrees. So about 46 degrees. And I'm going to call that A1, okay, because it did exist. Okay, so I got that guy to be 46 degrees. So this guy is going to be 46 degrees. Now, what we have to ask ourselves is, does a second triangle exist? Okay, so does a second triangle exist in this case? All right, well, how are we going to figure it out? Well, remember that if a second triangle exists, then I can have a second triangle by just taking 180 minus the angle that I just found. Okay, so I'm going to take, so this second triangle, if it does exist, I'm going to take 180 minus this A1. It's going to be 180 minus 46. So that's going to give me 180 minus 46, which gives me 134 degrees. Okay, so I got an angle. Now, how do I know whether this is going to exist or not? So what I'm going to do with this A2, what am I going to do? So let's go back. So I'm going to take A2 and add it to the original angle. So what was my original angle? So the original angle that they gave me was 68.7. So I'm going to take the 68.7 degrees and I'm going to add it to this 134 degrees. So when I add this, I'm going to have 68.7 plus 134. That gives me 202.7. This number exceeds 180. So does a second triangle exist? No. Only one triangle. Okay, so only one triangle is going to exist, which is going to be this guy. Good. All right, so now that I know that guy, okay, so this is going to be 46 degrees. All we have to figure out is what this angle C is. Okay, so that angle C is going to be really easy because angle C is just going to be 180 minus the sum of the other two angles, which is 68.7 plus, what was it? The other one, 46. Okay, so I'm going to take 180 minus 68.7 plus 46. This is going to give me 65.3 degrees. Okay, and then finally we can just figure out the value of C, of little c right here. Okay, so then we're going to use sine C over little c, and then I can choose whichever I want. So I'm just going to use sine B over little b. So sine C is going to be sine of 65.3 divided by little c, which I don't know. Sine B, so B in this case was equal to, what was B? 68.7. divided by little b, and little b in this case was 25.4. So I'm going to cross multiply. This is going to give me 25.4 sine of 65.3 is equal to c sine of 68.7. Okay, and then I'm going to divide by sine of 68.7. Okay, so then little c is going to be equal to whatever the heck that is. So 25.4 sine of 65.3 divided by sine of 68.7, which is going to give me 24.8. This is going to be inches. Okay, so that's going to be my solution. So here was a perfect example of only one triangle existing. Okay, so let's try this guy. So let's say I want to solve, this is the measurements. A equals 17.9 centimeters. Little b is equal to 13.2 centimeters. And big B is equal to 75.3 degrees. Okay, so drawing the triangle again. So let's say this is B. This is going to be 75.3 degrees. So across from it is going to be little b, that's 13.2 centimeters. Then you're going to have your A. Let's just label this A. I don't know what that A is, but I know this little a, which across from it is 17.9, and the other guy is going to be C and little c. Okay, so now we're going to use the law of sines. Clearly, this is the ask case again. So we're going to do sine B over little b equals sine A over little a. So sine B is going to be the sine of 75.3 degrees divided by little b, which is 13.2 centimeters. Sine A, I don't know what that is, and little a is going to be 17.9. All right, so cross multiply, so that's going to be 17.9 sine of 75.3, and then 13.2 sine of big A. So I'm going to divide by 13.2. So I'm going to get sine of A is approximately equal to, so whatever the heck that is. So 17.9 sine of 75.3 divided by 13.2. And that's going to give me 1.31. Now notice here that this exceeds 1. So you could have stopped right here and said, this is going to be no triangle. I'm going to go ahead and take it a little further so that you guys can check. So take sine inverse of 1.31. And what you're going to get is a domain error. So what can we say? No triangle exists. So at this point, all you can just do is just stop and not do anything else. Okay, so no triangle existing is actually the best one because then you don't have to worry about the rest of them. But that's basically what this guy, how you do these law of sines, especially in the ambiguous case. So in the next video, I will do a problem where you have to do true triangles.